Now, this is the example graph. On that example graph, we have to implement BFS on that graph. To implement BFS on this graph, we have to use Q data structure. Okay, Q follows a principle called first in, first out. Which element enters into the queue, that element is taken out from the queue first. Okay. Next, what is the maximum size of the queue we have to take? So, the maximum size of a queue can be taken by deciding how many number of vertices in a given graph. The total number of vertices in a given graph is equal to 8. Okay, so then we have to take maximum size of the queue is equal to 8. So we have to take 8 cells. So that size of the queue is equal to 8. Okay, now this is the algorithm we have to apply for finding out the BFS spanning tree. Okay, now first step. Visit the starting vertex and make it as visited. Okay, so this is the given graph. In that graph, we have to take starting vertex capital A. Okay, then that starting vertex is visited. Now we have to visit vertex A. Okay, next one, display the vertex. Display the vertex means in the visiting vertices, we have to write the starting vertex A. Next one, set a pointer to the starting vertex. So this starting vertex is also called as currently working vertex. So now we have to set a pointer to the starting vertex or currently working vertex. Starting vertex is A. We have to set the pointer to starting vertex capital A. Next, go to step 2. If currently working vertex has adjacent unvisited vertex. Here currently working vertex is capital A. This capital A has adjacent unvisited vertices. Okay, capital A has adjacent vertices, vertex B, vertex C, vertex D. So these vertices are not visited. Only vertex A is visited. So these vertices are not visited. So this condition is true. If currently working vertex is capital A has adjacent unvisited vertex. So A has 3 unvisited vertices that are adjacent B, C, D. So that this condition is true. If the condition is true, then go to this if block. Okay. In this if block, visit the adjacent unvisited vertex and make it as visited. So among the 3 adjacent vertices of capital A, we have to take one vertex, that is B, that is visited. Now vertex B is visited. Insert into a queue. Okay, so this vertex is inserted into a queue. Okay, inserted into a queue. Next one, display it. So now the vertex B is visited. Okay, now if this statements in the if block are executed, then there is no need of go to else block. Okay, after that one statement, repeat step 2 until Q is empty. So here Q is empty? No, Q contains one element capital B. Okay, so if this condition, repeat step 2 until Q is empty. Now go to step 2. Q is not empty. Because of that reason, go to step 2. If currently working vertex has adjacent unvisited vertices, currently working vertex is capital A. This capital A has any adjacent unvisited vertices are there. So there are 3 adjacent vertices B, C, D. Among the B, C, D, vertex B is already visited. Okay, then C and D are not visited. Okay, now we have to take vertex C. If this condition is true, because currently working vertex capital A has adjacent unvisited vertices C and D. So because of that reason, this condition is true. Then go to the if block. Visit the adjacent unvisited vertex and make it as visited. So among the two vertices C and D, so C is visited. C is visited. Insert into a Q. So C is inserted into a Q. Next one, display it. So now we have display the vertex C. Next, if this condition is true, there is no need of go to else block. So after that, repeat step 2 until Q is empty. Here Q is empty? No, Q is not empty because B and C are there in the Q. Okay, now go to step 2. If currently working vertex has adjacent unvisited vertex. Okay, so currently working vertex has capital A. This capital A has adjacent vertices B, C, D. Among B, C, D, B and C are visited, but D is not visited. Yes, this condition is true. Here capital A has unvisited vertex capital D. Okay. Now this condition is true. Then go to the if block. Visit the adjacent unvisited vertex. So adjacent unvisited vertex is D, vertex D, and make it as visited. Next one, insert into a Q. Now we have to insert capital D into a Q, display it. Now we have to display the vertex D. Okay. Now there is no need of go to else part. After that, you have to go to this statement. Repeat step 2 until Q is empty. So here Q is not empty. Then go to step 2. If currently working vertex has adjacent unvisited vertices, so capital A has three vertices that are adjacent B, C, D, but B, C, D are visited. So because of that reason, here capital A has 3 adjacent vertices B, C, D, all are visited. There is no vertex that is unvisited. Okay, so now this condition is false. If this condition is false, go to the else part. So in the else part, update the pointer to the first element in the Q. Okay, in the Q, what is the first element? What is the first element that enters into the Q? That is B. Now update the pointer to first element in Q. In the Q, the first element is capital B. Now update the pointer from capital A to capital B. Next one, remove the first element from the Q. So in the first element in the Q is capital B. Now remove the element from the Q. Okay, we have strike out vertex B. Okay, next one. After that, repeat step 2 until Q is empty. Okay, so here Q is empty? No, because C and D are there in the Q. So then go to step 2. If the currently working vertex, now currently working vertex is capital B. Okay. Currently working vertex has adjacent unvisited vertex. Yes, capital B has 2 adjacent vertices that are not visited. Capital E and capital F. So yes, this condition is true. Then go to this part, if block part. Visit the adjacent unvisited vertex. Okay, so among the 2 adjacent vertices of vertex B, we have to take vertex E. Insert into a Q. So now vertex E is inserted into a Q. Next, display it. Now we have to display the vertex E. Okay, so after executing all the statements in the if block, there is no need of go to else block. Then after that, one statement is repeat step 2 until Q is empty. So here Q is not empty. So because of that reason, we go to step 2. Next, if currently working vertex, here currently working vertex is capital B has adjacent unvisited vertex. So capital B has two adjacent vertices. Among the two adjacent vertices, vertex E is already visited. Vertex F is not visited. So currently working vertex B has adjacent unvisited vertex capital F. So this condition is true. Then go to the if block. Visit the adjacent unvisited vertex and make it as visited. So here this vertex is unvisited vertex, that is adjacent to B, and this vertex is visited. Insert into a Q. So that is F is inserted into a Q. Display it. So we have to display the vertex F. So if all the statements in the if block are executed, there is no need to go to else block. After that, one statement is there. Repeat step 2 until Q is empty. Here Q is empty? No. In the Q there are 4 elements are there. So that repeat step 2. Okay. If currently working vertex, that is B, has adjacent unvisited vertex, so there are no unvisited vertices for vertex B. Here E and F are already visited. These are the two vertices that are adjacent. There is no unvisited vertices for currently working vertex B. Okay. So now this condition is false. So then it goes to, in the else part, there are two statements are there. First one is update the pointer to the first element of the Q. So in the Q, what is the next first element? That is C. So now update the pointer to the first element of the Q. Okay. So first element of the Q is C. So now pointer can be moved from vertex B to vertex C. Remove the first element from the Q. So first element in the Q is C. Now remove that element. Okay. After all the statements in the else block are executed, then go to this step. Repeat step 2 until Q is empty. So here Q is not empty, then go to the step 2. In the step 2, currently working vertex. Now the currently working vertex is vertex C. Has adjacent unvisited vertex? Yes. C has one unvisited vertex, that is C. G. Okay. So this condition is true because currently working vertex C has unvisited vertex capital G. So if this condition is true, then go to the if block. So visit the adjacent unvisited vertex. What is the adjacent unvisited vertex for vertex C? Only G is there. So then it is visited. Okay. Insert into a Q. So now we have to insert into a Q. So that is G is inserted into a Q. Display it. Now we have to display the vertex G. Next, if all the statements in the if block are executed, then go to the repeat step 2 until Q is empty. Here Q is empty. So no. Q contains 4 elements. Then go to step 2. If the currently working vertex, that is C, has adjacent unvisited vertices, so there are no unvisited vertices for vertex C. So now this condition is false, so that it goes to the else part. Update the pointer to the first element of the Q. So after that, the first element of the Q is D. So update the pointer from vertex C to vertex D. Okay. Next, remove the first element from the Q. What is the first element in the Q? So that is D. So D is removed from the Q. Okay. Next one. After that, repeat step 2 until Q is empty. So there are 3 elements are there in the Q. So then it goes to step 2. Now, If the currently working vertex, now the currently working vertex is D, has adjacent unvisited vertex. So D has one adjacent unvisited vertex, capital H. So this condition is true. Then go to the if block, visit the adjacent unvisited vertex and make it as visited. So unvisited vertex for adjacent of D is capital H. This is visited. Insert into a Q. So now this H vertex is inserted into a Q. Display it. We are display the vertex H. Then all the statements in the if block are executed. There is no need to go to else block. After that, repeat step 2 until Q is empty. Here Q is empty? No. So then we go to step 2. If currently working vertex has adjacent unvisited vertex, so D has only one vertex that is adjacent, that is already visited. Okay, so this condition is false. Go to the else part. Update the pointer to the first element of the Q. So after that first element of the Q is E, then update the pointer to vertex D to vertex E. Okay. Next one, remove the first element from the Q. So what is the first element in the Q? So that is E. E is removed from the Q. Okay. Next, after performing the two statements in the else block, then go to this statement. Repeat step 2 until Q is empty. Now Q is empty? No. So then go to the step 2. Now, if the currently working vertex has adjacent unvisited vertices, now currently working vertex is capital E. This vertex E has no adjacent vertices. So this condition is false. Then go to the else part. Update the pointer to the first element of the Q. What is the next element in the Q? F. So now set the pointer to the vertex F. Okay. Next, remove the first element from the Q. What is the first element in the Q? That is F. F can be removed. Okay. After performing this step, then go to this step. Repeat step 2 until Q is empty. So Q is not empty because it contains two vertices H and G. Okay. So then go to step 2. If the currently working vertex, that is F, has adjacent unvisited vertex, there are no adjacent unvisited vertex for vertex F. So now this condition is false. Go to the else part. Update the pointer to the first element of the Q. What is the next element in the Q? That is G. So update the pointer to G. Okay. Next, remove the first element from the Q. In the Q, first element is G. G can be removed. Okay. Next, after the else block, one statement is there. Repeat step 2 until Q is empty. Q is empty? No. In the Q, vertex H is there. Okay. So then go to step 2. If the currently working vertex has adjacent unvisited vertex, currently working vertex is G. G has any adjacent unvisited vertices. So there are no vertices that are adjacent for vertex G. So that this condition is false. Then go to the else block. Update the pointer to the first element of the Q. First element of the Q is H. So then update the pointer from G to H. Okay. Next, remove the first element from the Q. So in the first element of the Q is H. H can be removed. Okay. Next one. After that, one statement is there. Repeat step 2 until Q is empty. So here Q is empty. Yes, Q is empty. It does not contain any element. Okay. So now this is the order of visiting of vertices for this graph by using BFS is A, B, C, D, E, F, G, H. Okay. So this is the answer. So in this way, we have to implement the BFS, breadth first search technique on this graph G. This is the order of visiting of vertices. First, we are visiting the vertex in the level 1. So this is level 1 and this is level 2 and this is level 3. First, we are visiting the vertices in level 1, that is vertex A is visited. Then go to the level 2, B, C, D are there. We have to visit all the vertices in level 2, B, C, D. Next, visit all the vertices in level 3, E, F, G, H, E, F, G, H. So this is the visiting of vertices for a given graph G by using BFS. For that purpose, we have to use Q data structure. Now, so this procedure we have to follow. Thank you. Thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasa.